Folks, can you hear me? Please type yes in the chat window if you can hear me. Also, if you can see the screen. Thanks, Srinivas. Thanks, Tejas. So I'm by myself today here. Don't have a second moderator, so this is going to be a little bit tricky, both presenting as well as moderating and checking for questions. So what I'll do is, hi Prashant. So what I'll do is I'll take questions every couple of slides. I'll not be able to answer your questions right away because I'm here presenting by myself without a second moderator. So I'll every couple of slides I'll try and come back to the chat window and pick up the questions. Okay. Thanks, Prashant. Thanks, Prashant. That will do. Yeah, you can. Every couple of slides I'll try and come back to the chat. Also, I want to apologize because there might be a little bit of background noise because there's some construction activity happening next door. So maybe a little bit noisy in here, but we'll try our best to make sure that both the audio and video are as smooth as possible. In case you encounter any audio or video issues, please let us know ASAP. We'll begin in 2 minutes. All right, I think we can begin now. Present. Okay, hope everyone can see the screen. Hi, hello, welcome to today's session on Git and GitHub. My name is Mithun Shanbag. So I run SKU Code, which is a programming education startup. So we do corporate trainings, we do classroom trainings, and we do online training as well. So we mostly focus on mean stack programming, so everything related to JavaScript and web development. So we have courses on AngularJS, React.js, Node.js, web front-end development, mean stack development, and all that. So you can go to our website, www.sqcode.com, for more details. With that out of the way, let's begin. Crash course in Git and GitHub. Okay. All right, so the table of content. So we'll be going over distributed version control system, and we look at what that is. We'll look at how to install Git and get it on your machine, up and running on your machine. We'll look at some basic concepts of Git, like what's a working directory, what's the staging area, what are commits. So we'll look at the, you might have heard of those words pretty often. So we'll look at what they mean. We'll look at branching, and branching is what really makes Git very powerful. So we'll look at that. We'll look at remotes and remote tracking branches. We'll look at merging, and we'll pretty much end there today. We'll not look at things like rebasing and all that. Don't want to make it too complicated. We'll probably do another session to cover the more advanced Git topics, Git hooks and all those stuff. All right. Distributed version control system. Okay. So generally, there are two kinds of version control system. The ones that we are traditionally used to, like Perforce, SVN, or TFS, Team Foundation Service, etc. So they are what you call as a standard version control system, or VCS. So in a standard version control system, so I'm looking at the diagram on my left here. It's a version control system, which means all the version history will be stored. However, each client that connects to it only doesn't get the full copy of it. It generally gets only partial copy of it. So it means that if the central repository goes offline, then the clients are pretty much stranded. They can't sync, and you're not able to do your operations anymore. So that's really a big bottleneck. So let's say you're encountering network connectivity issues, or if the central repository's server and it encounters a disk failure or something like that. Without connectivity to the central repository, you're pretty much hosed. So to alleviate that, we have something called as a distributed version control system, where not only does the central repository have the entire version history, but each client connecting up to the source control to the central repository has the version history as well. So if you lose connectivity to the central repository, you can still continue doing your work, and you just have to wait until the central repository comes back up, and you don't have any interruptions at all. So let's see if there are any questions on YouTube. Srinivas Rajgopal asks, will the video be available later? So yes, Srinivas. Yes, on the same link. So Srinivas, what happens is once the webinar ends, the video is automatically preserved in the same location. So no worries there. Okay. All right, let's look at how to install Git. So as far as installation goes, the very first thing you would do is go to this website called git-scm.com. So let's play along. git-scm.com. So this is the one-stop shop for everything Git related. So you'll see a location, download location. So I'm currently running a Windows machine, but if you're running a Mac, you'll see a download link for Mac or Linux accordingly, depending on which flavor of operating system you're running. So go ahead and download that. I already have it, so I won't be doing it again. So go ahead and download that. So this website is your one-stop shop for everything Git related. They also have an awesome documentation, which is so there's this book here called Pro Git, which is one of the best books on Git that I've read. My recommendation would be, do take some time. If you're always confused about Git, do take some time out to go through this book. Really well written, and the entire book is available here online. So things like, for example, you're confused about what remotes are or how do you work with them. So everything is mentioned out here. All right. Okay. So, all right. So I hope everyone has had a chance to download Git. Next thing you would do is create an account on GitHub. It's a free account. You'll have to create public repositories. So go ahead and create it if you don't already have a GitHub account. So I already have one. So let's just say I'm going to create a new repository now. So let's just say new repository, and I'm going to call it Git demo. Okay, and I'll say this is for the Git webinar. Public repository. I'll say create repository. And that's it. Now you have created a GitHub project. So this is known as the clone URL, and we'll get to that in a second. All right. So now I'm assuming everybody has had a chance to install Git. So coming back. All right. So once again, install Git from git-scm.com. If you're running on Linux, you could do a sudo apt-get install git-all. For Mac users, you can do a brew install Git. For Windows users, if you use Chocolatey or any other package managers, I'm pretty sure there's a Git installation command there. I'm pretty sure it's like choco install Git or something like that. I haven't tried it in a while. But okay, the very first thing you would do once you install Git, let me start my own. Okay, so the very first thing you would do is you'd configure your username. So something like git config -- global, and I'll get to what global means. User.name, and give it some name. I'll give it some Shambal. Okay. The next thing we would do is configure our email address. I hope you guys are following along, trying it out on your own machines. User.email. Okay, so don't really need the codes here. Okay. So I'll get to what -- global means. So configurations in Git have three levels. You can have a global configuration, which means it is machine-wide. You can have a local configuration, which is per user profile, and you can also have a repository-specific configuration. I'm just going to assume that there's only one user on this machine, so I'm just going to use global to keep it simple. Okay. Next thing you want to do is git config -- global color.ui auto. So what this does is ensures that Git command outputs are colorized. So let's say, for example, you are doing a diff and you want the left side file to be shown in green and right side file should be shown in red. So this is what helps. Okay. All right. So the next thing we are going to do is this is an optional step. Feel free to ignore it. So I use an editor called Visual Studio Code, and I'm going to configure it accordingly. So I will do code.editor code -- wait. Okay. So this means that Git will actually wait for Visual Studio Code to actually exit before does any of its post processing. So if you don't have Visual Studio Code, feel free to ignore this step. Okay. Okay. And finally, you can do git config -- global -- list to see the set of configurations that we just set. Okay. There we go. Okay, let's check for questions. Okay, no questions. Okay, feel free to ask questions on the YouTube chat window. I will be checking in every couple of minutes there. Okay. All right. So now let's come to how do you create a local Git repository? There are two ways to do it. You initiate one from scratch, or you clone an existing one. Okay. So because we are working more with GitHub now, let's clone an existing one. Okay. So if you want to create a repo from scratch, you can go there. You can open up your command line. So let's say you can make a folder, call it test1, and you can go inside the folder, and then you could say git init. Okay. And there you see this .git folder. Once it gets created, it means that a local Git repository has been created. And that's all it takes to initialize a Git repository from scratch. Okay. So we'll delete this folder for now. Okay. And remember this Git demo GitHub project that we created. Now let's clone that. Okay. So the first thing we'll do is go to a location on your machine where you want to clone it down, and then we will create a folder. Let's call it test source. We'll call it Git demo src. Okay, and then you would do a git clone. Go to your GitHub project, and then copy the location. This is called as the Git project URL. So this is the location of the project on GitHub. So we are going to clone that down. Okay. It always ends in a .git. Okay. Then copy it. So that's, you're going to git clone from this source location to this destination, which would be git demo src. Okay. There we go. Copy it. If you're attempting this for the very first time, it may pop up an authentication dialog where you'll have to enter your credentials. If you're using a free GitHub account, then it shouldn't, because it's not you don't need any authentication access. All right, so let's go into this folder, git demo src, and there you see our README file has been copied locally. Okay, and if you do a dir/a, you'll see the .git folder as well. For folks on your Mac machine or Mac or Linux, you could do a ls-a and show you the same thing, hidden file. So this .git folder is a hidden folder, and we'll get to what .git means in a while. Okay. All right. So a bunch of folks have questions about whether this video will be available after the session. Yes, that's the magic of YouTube live webinars, which means once the webinar is finished, you can always, the video will always be available immediately at the same URL location. So you could, a minute after the webinar ends, you can start watching the video straight away. Okay. And also, we'll put the links to the slide, code samples, etc. In the video description. So no worries. All right. So okay. So now that we've cloned, let's move forward. Okay. All right. Now we come to the most interesting concept. All right. So Git local repositories, essentially, they're comprised of three portions essentially, or the entire Git repository, remote repository as well as local repository. You can think of them as having 4 portions. So the one highlighted in yellow here is called as the working directory. This is the folder that you cloned it into, right? So this is your working directory. This is where you make your changes, test it out, this is sort of like a test scratch pad, if you will. You test your changes here, you make changes here, and let's say you make a change here. Let's say you added a file called x1, or you change the state of the working directory to to be x1 essentially. All right, maybe you added a file, maybe you edited an existing file. So now the state of the working directory is x1. Okay. You can always view the status by running this command called git status or my preferred thing is git status -s, which shows you an abbreviated version. But anyways, next thing is called as the staging area. So once you made changes and you're pretty sure that the changes look stable, you can get them staged in this staging area. Okay, the staging area is also known as the index, and you can run this command called git diff to see the difference between the working directory and the staging area. And I'll show you a live example. Okay, so you would do a git add to add your changes into the staging area. Okay, doesn't matter if it's a file edit or a file removal or a file addition. You always run a git add, okay, to commit something to the staging area. That's how you get your change x1 into the staging area. So we have a question saying, can you mail us the cheat sheet? Yes, I'll be putting up the cheat sheet in the YouTube video description, so no worries. This question was from Prithvi, so thanks, Prithvi. Okay. All right, and then once your change is in the staging area, you can make a commit object out of it by running this command called Git Commit. Okay, and that's how you get a local commit object. Okay, and you can view the difference between the staging area and the local repository by running this command called git diff --stage. Let's do an example here. I mean, enough theory. Let's rewind back. Okay, so let's say I'm changing the state of the working directory to x1. Okay, so let's do that with an example. So let's say where am I? Okay, so I have a readme file here. So let's say I create a file called okay, let's do it from the editor. So I'm launching Visual Studio Code in this folder. Okay. All right, so I'm going to create a new file here, and I'm going to call it welcome.md. Right, so we already have a readme.md. I'm going to create a welcome.md, and I'm going to write something. Welcome to Qcode's webinar on Git. I'm going to save that file, and that's it. Now I can run this command called git status -s, and it shows me. I hope you guys can see clearly. There are 2 question marks and welcome.md. So what this means is Git now 2 question marks means untracked file. Okay, a file can be in one of several states. It can be tracked or untracked. If it's tracked, then it can be it can be modified, edited, etc. So so you see these 2 question marks, welcome.md. It means Git detected there is a untracked file in this folder that it knows nothing about. All right. So we've added a file called welcome.md, which is x1. Okay. So now we need to we need to stage this file. So next thing we are going to do, let me increase the font size here. Okay. Okay. And next thing I'm going to do is run git add welcome.md. Okay. Now check the status. So it says the file is A and green. A is added. So it has been added to the staging area. Okay, so whenever I frequently run this command git status -s. Whenever you see anything red, it means there's still work to be done, right? So that's a rule of thumb that I follow. Okay, so there's a question from Pranay. If there's a merge conflict, it shows difference between two. How does it? Oh, 1 second. So the question is about merge conflicts, and Pranay, I will answer everything about merge conflicts towards the end of the session. We'll actually be doing a live example to look at how to resolve merge conflicts. Okay. So we run git status dash s. Okay. Okay. We did a git add welcome.md. So we added the file. So now your file welcome.md is in the staging area. Okay. And now we could run, let's say, I'm going to edit that file further. Okay, so I'm going to do welcome.md. Okay, so I've edited this file now, saved it, and now I run git status -s. It shows that there is an added file, so it says AM. M is in red, which means there's work for us to be done. We need to do work. So it shows that the file was added and then modified. Okay. And now if you run a git diff, okay, it shows the difference. This is what is in the staging area, the one in the red, and the one in the green is what's in the working directory. So you remember this git diff command, the one which compares the staging area to the working directory. We just ran that. Okay. All right. So now we need to push our changes into the staging area. We simply do a git add again. Okay. And now we run a git diff. It shows no difference. And if it is expected because now we push the changes into the staging area. And if we do a git status -s, it shows the file has been added. So all the changes have been added. There are no pending modifications, right? Okay, so that covers git status, git diff, and git add. All right. So now we need to push these changes. Now we need to push these changes from the staging area into the local repository, and we do that using this command called git commit. Okay, so git commit will take a snapshot of the staging area and create a commit object out of it. So commit object is a full history. Srinivas Rajgopal has a question. What is the necessity of using staging area? Can't we directly commit the file? Yeah, you could, but the general rule of thumb is, make sure it goes into a staging area, test it out before you create a commit out of it. So it's like a scratch pad, if you will, right? Yes, you do your frequent changes in working directory. When you feel comfortable that you feel you have a final change, put it in the staging area. You test it out, you discover some bugs, go back to the working directory, make some changes, get them into the staging area until you're fully comfortable, and finally create a local commit out of it. It's just the way Git works. And also there are like data structures that represent each of them, and I'll get into that in a later slide. I hope this answers your question. Right, so now let's run git commit. This is tedious, switching between PowerPoint and the command shell. Okay, all right, so if we run this command now, git diff --staged, okay, here you can see that it compares the staging area to the local repository. Okay. It shows that. So we don't have anything in the local repository, so that's empty. And we have this line in the staging area. Okay. So now let's run git commit. And I generally prefer to use the -m version, which is give a message, commit message. And I can say committing welcome .md to local repository. Okay, there we go. So now we've created a commit out of it, and now if you run git diff --stage, there won't be any diffs because all the change was pushed from the staging area into the local commit. Okay. You can run git log now to see a list of local commits. So here you'll see two commits. Um, this is the one that we just did, committing welcome.md to the local repository. And this commit is the initial commit that was done when we created the GitHub project and we cloned it down, right? So when you create a GitHub project, that's also a commit, and the history is preserved and pulled down when you did a Git clone at the very beginning. So essentially, you see that there are two commits here. Okay. All right. So now let's look at the interactivity between local repository and remote repository. So your remote repository is your GitHub repository, so github.com. We can do a git push to push our changes, and similarly we can do a git pull to pull the changes. I will know fetch is a little different. I'll explain how fetch and pull differ in a later slide. But yeah, now to get our changes into the GitHub repository, we simply do a git push. Okay, so I can do a git push, and it'll push the changes. It'll push welcome.md into the GitHub remote repository. So right now you can see there is no welcome.md here, but if I refresh this now, welcome.md has been pushed to the remote repository. So this explains, more or less explains the how various pieces are related to each other and how they interact with each other. So just to recap, 4 areas, and this is pretty important. So you have your working directory, you have your staging area or index, you have your local repository where all the local commits go, and you have a remote repository which is github.com or bitbucket.com, or one of those remote Git repositories. Make a change in your working directory. You can see the status using git status -s. You can see the diff between staging area and working directory using git diff. You push your changes to the staging area using git add welcome.md in our example. That gets the change into the staging area. Now to get the change from staging area into the local repository, you would run a command called git commit. Git commit gets the changes into the local repository, which you can finally push into the remote repository using git push. Okay. Also, you use git diff --stage to compare between local repository and staging area. And finally, you do a git push to get your change in there. Okay. And similarly, you can do a git fetch or git pull to fetch the changes from the remote repository. We'll look into that. Okay, so now let's say we make another change. If you're observing the state of the working directory, let's say we made another change. Let's say we added another file, or we modified one of the existing files. So now state of the working directory goes to x2. Okay, we git add that change, and now staging area is x2 as well. Okay, the state of the staging area is now x2. We do a git commit. The interesting thing here is x2, a commit object is created out of x2, but it doesn't overwrite x1. It points to x1. So 2 commit objects get created. So remember, each commit object is the full history. So you can't just nuke history. You can't just delete history. You have to preserve the history. So x2 is a full representation of the commit, and it will point to x1. Okay, so as part of its history, and that's what we did, right? We ran git log, which showed all the existing commits in that happened locally. Okay, so we'll do a quick example. So we'll go add a file, or we'll go modify the existing file. Okay, so here's welcome MD. Okay, so I'm going to save this file. Okay, it shows that the file was modified, so I'm going to git add it. Also, git diff to check the difference between working directory and staging area. Quickly add this file. Okay. Okay, and now do a git diff dash dash staged. Okay, there's a difference between the staging area and the local repository. So now we do a git commit dash m, say updating welcome. Now I've committed it. Now git diff dash dash stage will not show any diff, right? And now do a git log, and then we'll see, our change has come here. So commit number X. So this would be X3, this would be X2, this would be X1, right? So you see X3, X2, X1. We have a question from Pranay. Git push origin branch name. Yes, Pranay, I'll get into. I haven't gotten into remote branches, remote tracking branches, and branches yet. So origin is what you call as a remote tracking branch, and I'll get into it in a bit. Origin is what you call a remote, and then I haven't introduced branches yet. So please wait for a couple more slides, and we'll talk about git push origin branch. Okay. All right. So all right. So there you see, this is X3, X2, X1. Right? They are not overwriting each other. They are preserved independently. All right. On to the next slide. Okay. Git remote. Okay. So here's our local repository, and here's our remote repository, right? And the remote repository can be github.com, Bitbucket, one of those remote Git. You can have a Git server hosted locally as well, and it has a URL. And let's look at the ways in which local repository and remote repository can interact with each other. Okay. So first and foremost, we'll run this command called git remote -v. So git remote -v. Okay. So you'll see this word origin pretty often in Git. Okay, and people have always wondered about what does origin mean. What does remote mean, or what does upstream mean? And I'll answer all that. So run this command called git remote -v. -v stands for verbose. If you just run git remote, you get this. Okay, origin. So it will be a little bit more descriptive here. So origin is an alias which points to the remote repository. Okay, origin is just an alias which points to the remote repository. So think of it as a shortcut that refers to the remote repository, right? So you have your local repository, you're on that machine, and you are interacting with the remote repository, right? So this origin is a shortcut or a alias which refers to this remote repository. Okay, and there is fetch and push URLs. 99.99% of the time they'll be the same, unless you may have some. You're working in an organization where you are fetching from a read-only server and you are pushing to a write-only server. Very rarely will that case happen. Fetch and push URLs will be the same. So yeah, origin is just a shortcut which refers to the remote repository. So instead of typing this entire thing, you can just type origin, right? So that's what a remote means. So git remote essentially refers to that shortcut which points to the remote repository. Okay, in this case, origin. So let's look at it. So you would add a remote. So when you did a git clone, you automatically got the remote. Okay, you automatically got a remote called origin, which is pointing to the remote repository. However, you can add one manually yourself called git remote add. You can using the command git remote add. You give this the name something like origin to my remote my remote one, whatever you want to call it, right? And here's the remote repo URL. Okay, so that's how you add a remote. When you add a remote, physically nothing happens. Only thing is you set the upstream, or you set the remote. You essentially initiate some sort of a connection between the local and remote repository. It means you're telling Git that here's a local repository. Should I ever run a push operation or a fetch operation or a pull operation, here's the remote repository that I want you to interact with. So it's just a way of telling Git which remote repository you're working with. Okay. So when you do a clone operation, everything is automatically set for you. The remote is automatically set for you. If you are initiating a Git remote from scratch using a command like git init or something like that, then you would need to add a Git remote. Okay, so you would add a Git remote using the command git remote add. Okay, and of course you would fetch using that remote. So git fetch or git pull using that remote. And here comes the question which someone asked. Git push origin branch name, and that's how we do it. So git push. If you don't specify anything, it will just look at what the default remote name is, which is origin, and the default branch name, which is master, and I'll get into that. But you can also specify git push where what. Okay, git push where to push, what to push. Okay, git fetch where to fetch from, and then you can also optionally specify the branch name to say where to fetch to. So think of it this way: git push where to fetch from, where to push, what to push. Okay, the contents are in a branch. The destination is specified by the remote. Okay, origin in our case. Okay, and similarly, you can remove a remote as well. Git remote remove, and then the remote name. Okay, so as an example, I'm gonna so here's our list of remotes, right? So I'm going to add a remote, and I'm going to call it origin2. Okay, I'm going to point to the same location. I can make it point to anywhere. Let's just make it point to the same location. Okay, I'm going to call it origin2. Now let's run git remote -v. So both origin and origin2 are pointing to the same location. Okay, great. Now I'm going to add a file. So going back to code. So I'm going to modify this file and say, hope you enjoyed today's webinar. Hope you enjoyed today's session. Okay. I'm going to save this file, and I'm going to do a git add welcome and git commit -m. More changes to welcome.md. So this has gotten it into the local repository. Now I'm going to push using this new remote that I created called origin2. Okay, I can specify a branch name, but given that we are on the default master branch, I don't need to. So I'm just going to say git push origin2, and that's it. So now this file has been pushed to the location specified by origin2, which is the same as the original location. So now if we come and refresh this file, you'll see you'll see this, the changes that we just made. There you go. So the changes appeared here. Reverse is also true. Like we can edit this file here. Okay. Let's just make this change here. So we made a change to the remote location, and we're going to pull it using git pull. Okay. Now normally I can just specify git pull, and it will pull from the default remote, which is origin. But I can also pull it from origin2, which is also the same thing. Okay, so pull into a branch. So we'll specify master. Okay, so that's it. And now if we run, you see that the changes that we pulled are now here. Okay, we pull those changes using origin too. Okay. All right. So hope that answers questions about Git remote and what does upstream mean, what does origin mean. Now I'll spend a couple of minutes. Actually, I think enough questions have accumulated, so I'm just going to go answer some of these questions. Merge conflicts, Pranay, please wait for a couple more slides. I'll do a live demo on how to resolve merge conflicts. Necessity of staging area, we've answered this. We have git push origin branch name. Origin, what does origin mean? I just answered it. If we have two branches, can we push changes from one branch to another branch? No, that's not how it works. You push operation always pushes stuff from local repository to remote repository. No, it doesn't. It will push to the same branch. The source and destination branch names will be the same. If you can create a separate branch and you can push changes. You can pull changes from a second branch into the first branch using an operation called merge or rebase, and I'll get into that later. Okay, can a local repository point to multiple remote repositories? Yes, it can. For example, I do this. I work with a local repository and I save, just to take backups. I have one remote pointing to GitHub, another remote pointing to Visual Studio Online, another remote pointing to Bitbucket. So I push it to all three locations. So you can do that as well. So yeah, it's possible for a local repository to point to multiple remote repositories. Good question. Can there be multiple remotes? Yes, as I just showed you, I just added a second remote called origin 2. Can you explain branches? Next slide, it's coming up. Okay, and looks like Prashant has answered quite a bunch of questions. So thanks, Prashant. Okay, let's move on. Sorry. Where's my slide? There we go. Oh yeah, and git remote remove, right? So let's remove git remote remove origin 2 git remote -v. We'll come back to its original state. Let's go origin. Okay. All right, next slide. I think everyone's favorite topic, which is branching. All right, so branching. The most powerful Git feature. This is why Git is really popular, because branching is cheap and cheap. When I say cheap, I mean blazingly fast. If you've used other version control systems like Team Foundation Server or Perforce, you would know what a nightmare branching is. So for example, you have a 20 gigabyte repository and you are creating a child branch out of it. So it has to copy every single file from the parent branch and create a clone out of it in the child branch. So the operations is expensive, not only in terms of time, but also in terms of disk space, right? Because you're copying everything, you're creating a duplicate copy out of it. So you essentially end up doubling your disk space utilization. So in Git, however, branching works a little differently. And the trick really is to forget everything you've learned about branching in older version control systems. So let's just look at an example. Excuse me. All right. So the key takeaway is in Git, a branch is nothing but a pointer to the latest commit. Okay. So this may feel a little weird to hear, but a branch, master, for example, right? The master branch, it's nothing but a pointer to the latest commit. Okay. So we'll look at an example. So you have the working directory. You make some changes called x1, right? So by default, the only branch that exists is the master branch. You can create new branches. The purpose of branches really is to make sure that you're isolating your work. Let's say you're making your team is working on a feature or you're fixing a bug. You generally don't tamper with master. So master is more like a pull only branch. You don't really make change. It's like a production branch, right? You don't make changes there. You make changes in a child branch, and then fold or merge your changes into master after having tested it thoroughly. So you test it in the child branch and then merge it into master. Okay, so that's the general workflow. So, but in this case, let's just make changes in master directly. We'll look at making changes in separate branches in a different slide. Okay, so we have our x1. As usual, we add our change, get it into the staging area, commit it, and x1, right? So as I mentioned before, a branch is nothing but a pointer to the latest commit. So master is pointing to x1. Okay. Now we make a change to the working directory. Let's say we added a file or edited a file or something, and now working directory state is x2. We add it. Staging area state is x2. We git committed, and now new commit is created x2. Now remember, branch is a pointer to the latest commit. Okay, so branch will now point to the latest commit. So master is now pointing to the latest commit x2. Okay. Similarly, make more changes. x3, add it to the staging area, commit it, and create a local commit. x3, branch being a pointer to the latest commit will now move to point to x3. Okay, so master will now point to x3. So remember, so that's what it is. Branch is a pointer to the latest commit. Okay, and now let's look at an example of why branching is so easy in Git. Right, so I git committed it. Git committed my change x1. Okay, we just went through this example. So master will move to point to the latest commit x2. Okay. So let's look at this example here. Okay. So we've made a couple of commits, right? So we can do a git log. We can see 1, 2, 3, 4. There are 5 commits. So yeah. So now let's run this command called git branch dev branch. Okay. So what this will do is it will create a new branch. Okay. Just run git branch. It will show you the list of branches, right? Or run git branch -v. It will show you master is pointing to this commit. Okay. Okay. So this is what you call as a SHA-1 hash, which describes the commit. And you can generally take like the first 7 characters of the SHA-1 hash to uniquely identify a commit. So as an example here, master is pointing to this SHA-1 hash, this commit essentially. First, so CFF081D, CFF081D. So the first 7 characters are enough to uniquely identify SHA-1 hash, which is essentially a commit. Okay. So right now you can see there's only one branch. So we're going to create a second branch, git branch dev branch. Okay. And there you can see a new branch was created called dev branch. However, master is still the active branch. Note that creating a branch and switching to that branch are 2 different topics. 2 different operations. So when you do a git branch dev branch, or git branch child branch, or git branch branch one, whatever, you are creating a branch, but you're not switching to it. Okay. So you switch to a branch using a command called git checkout dev branch. Okay. So let's do that. So we created the branch using git branch dev branch, and now we are going to git checkout dev branch. Okay, so you see we switched to branch dev branch. Okay, now if you run a git branch -v, the branch, the asterisk and the green thing will point to the active branch, which is dev branch. We switched. Okay, so we switched from master to dev branch. The interesting thing was, when we ran the git branch dev branch, the branch was created immediately. There was no cloning or anything. This was because, like I mentioned, a branch is nothing but a pointer to the latest commit. So when you create the branch called dev branch, essentially all you're doing is you're creating a pointer to the latest commit, which is x2, right? So see this again. You're creating a branch, which is the latest commit. X2 is the latest commit. That's it. That's dev branch for you. Okay. Nothing to copy, nothing to clone. That's it. You're just creating a pointer, which is why branching in Git is so fast and easy. You're just creating a pointer. Okay. Now we are running git checkout dev branch, which notice that link between the working directory and master branch. When you're checking out, it essentially means now the connection is from the working directory to dev branch, not to master. You're switching to dev branch. So now you see the link is between working directory and dev branch. Okay. So it means that working directory's contents will be replaced by contents of dev branch. But since both dev branch and master are pointing to x2, the state will remain x2. So no changes there. Okay. So essentially, every time you switch to a branch, the contents of the working directory are populated by that, whatever that branch is pointing to. And we'll get to an example. Okay. Questions so far? Let's look at. Oh, a lot of questions. Okay. So Prithvi has a question. So each branch can have a number of remotes. So remotes essentially have nothing to do with branches. Remotes just set up, like a connection between local repository and remote repository, right? Branch is an orthogonal concept. Branches exist both locally and remote, on remote thing, on local repository as well as remote repository. But branch and your remotes like origin are completely different concepts. Okay, Nitish has a question. Only remote repository has history, or working directory staging area also store history? So your local repository also has history. So when you ran the git log command, it showed you the local history, right? So this is all the history that you made, changes you made locally, list of commits that you made locally, as well as ones that you pulled down using git pull or git fetch. So history is preserved on both sides, right? And you synchronize them when you run a git push or a git pull. Okay, I think Prithvi had another question. I'm super confused between the difference of remote and branch. I thought remote were basically branches. No, Prithvi, remotes are not branches. Remotes are just aliases or shortcuts that point to a remote repository. What you are thinking of is something called as a remote tracking branch. Okay, I know this Git concepts are really confusing. Remote branch and remote tracking branch are, there are three concepts. So remotes are your shortcuts or alias to a remote repository. Branch is just that, pointer to the latest commit. You also have something called as a remote tracking branch, something like origin/master, which I'll get into in a couple of slides. Okay, good question though. All right, so we looked at how we created a branch and checked out that branch. So essentially, contents of working directory will now reflect to whatever's in dev branch, which is x2, which is same as a master. So no changes there. Okay. Now let's say we make some changes to the working directory and update the state to x3. Okay. So now we are going to git add x3 to the staging area, and we commit it. Okay. So now here's what happens. So x3 object gets created. Master is out of the picture right now. So master has no idea. Master is not the active branch, so it has no idea that a new commit has been created. But dev branch does, because it's the active branch. So as I said, branch is a pointer to the latest commit. So the latest commit is x3. So the active branch, dev branch, will move to point to x3. Okay, master has no idea that this commit even exists, so it stays in place. Only the active branch moves forward. Okay. So now what you do is you git checkout master. Okay. So now active branch becomes master. Okay. Now I want you to observe this red arrow. So till now active branch was dev branch. So contents of working directory and what dev branch is pointing to, which is x3, are the same. Now we'll do git checkout master, this command. So here's what happens. Contents of master are x2, and now working directory will be updated to reflect that content. Okay, working directory goes back to x2. Now let's say we make a change here called x4. Okay, we add that change, we get x4 into the git staging area, and we git commit it. So now we get x4, and now dev branch has no idea that x4 took place because it's no longer the active branch, but master does. Master, is being the active branch, will now point to the latest commit, which is x4. Okay, there you go. Okay, so this is essentially how branching works. So we'll take a look at an example. Okay, so git branch. Okay, so we are in dev branch right now. So we're going to create a file called let's say hello.md, right? So we already created a welcome.md in master branch. Now let's create a hello.md in dev branch. Okay, hello world. We'll save this file. So git status -s. Okay, so git add hello.md, git commit -m, adding hello.md. Okay, so now all these changes are being added in dev branch, right? So you run a git log here, shows that you're in dev branch, right? Okay, coming back to this now, if I check out the contents of my working directory. So I have a hello, I have a readme. Okay, now if I switch back to master branch, so if I do a one sec. So I'm on dev branch. Okay, and as you can see, I have hello and readme in my working directory. If I now switch to git checkout master, now I'm switching back to master. Okay, and as you can see, now I'm back on master. This hello.md existed only in the dev branch. So if you do a dir right now, you'll see hello.md has disappeared, because the working directory, whenever you switch a branch, the working directory state will be updated to point, to be the state of the whatever branch it is pointing to. Since master doesn't know about hello.md, hello.md will not show up here. Now, if we add a file, let's call it namaste.md. Let's add this file. Namaste Bangalore. Okay. And we run through the same motions. We add namaste.md, we git commit -m. Okay. Now let's switch branches. Git, which branch are we in? We are in master, right? Now let's switch to dev branch. Okay. And now you'll see that the namaste.md has disappeared. There you go. Because the contents of the working directory have been updated to reflect the branches. And the branch is dev branch, which has no idea that namaste.md exists, right? I hope this is clear. I'm going to take a couple of questions. Okay. So Pranay has a question: is there a difference between Git branch name and Git checkout -b branch name? Okay, so good question. So Git branch name will create a branch called branch name. So let's say I create Git branch my branch. So it's created a branch. Then I switch to the branch using Git checkout my branch. Okay, but you can unify those two commands using this Git checkout -b. Okay, so Git checkout -b not only creates a branch, but it also switches to it. So it's like killing two birds with one stone. So that's what it does. Muzibnet has a question: how to create more readable commit labels apart from SHA hash? Okay, good question. So more readable. Okay, so here we go. So I've been showing you this command called git commit -m, right, where I type in some messages. Okay, let's do an example here. So I'll take this hello.md and I'm going to modify it a little bit. So hello world, welcome to today's. I'm going to save this, git add hello.md and git commit. This time I'm not going to specify the -m, I'm just going to run git commit. Okay. Remember we had configured Visual Studio before, so this is what it is. Now I can enter a commit message here and say this is a very descriptive commit message. Generally in production, the way it works is like every change you have to be very descriptive. Chances are that you will not be the person who will be maintaining this code, and you will be working in a large team. So other people will be looking at your code. So it's generally best to be descriptive about what the change is, why it was made, how it was made, what tests were run to test those changes, etc. So you write like a couple of paragraphs, and that's essentially how you write descriptive commit messages, right? So if this was production code, this would be at least like 2-3 paragraphs to describe the change here. So you save this file, okay, and that's it. And now when you look at git log, it's your descriptive commit message shows up here. Okay. Okay, questions. If branches are used to make instances and for different people to work on different problems, what are remote used for? What was the point of origin tool? So, okay, so origin, like I mentioned, origin, the remote, essentially connects up local repository to remote repository. So as I mentioned in my example, I have a local repository and I generally connect it up to 2 or 3 remote repositories, right? So I save my code on GitHub, I save my code on Bitbucket, I save my code on Visual Studio Online. So Visual Studio Team Services. So essentially, I do a git push origin 1, that goes to GitHub. Git push origin 2, that goes to Bitbucket. Git push origin 3, that takes it to that pushes it to Visual Studio Team Services. So essentially, by setting up 3 remotes, I now push it to different locations. Okay. All right, so I think that's about the extent of questions. Now let's get back to branches. Okay, so now comes an even more confusing concept, which is called as a remote tracking branch. And I believe someone had asked about remote tracking branches. Remote tracking branches are not remotes, they are just branches. And I realize this is super confusing. It took me quite a while to wrap my own head around this. And once again, and I must mention that if you go to the git-scm.com website, go to documentation, go to books, and look at the ProGit book. There's an excellent chapter on what remote branches are. So remote branches, there we go. What are remote tracking branches? And I'll just explain that. I've taken most of my content from this book. Okay, so here's your local repository, here's your remote repository, and imagine that there's a line that divides that. Okay, so let's say remote repository is your GitHub. So you go to somebody pushes something to GitHub, master branch is pointing to that commit x1. Somebody made some more change x2, yet more change x3. Okay, and at that point you come join that team, and your very first step is to git clone or do a git fetch to fetch the entire set of changes that have happened on the remote branch. Okay, so at this point you run git fetch origin or git pull origin or just a git pull. Okay, so you will get a exact copy of that, right? You get x1, x2, x3 as has happened. Master is pointing to x3. But along with that, you get every time you run a fetch, pull, or a clone operation, you also get the remote tracking branch updated. Okay, so remote tracking branch is a branch, it's a pseudo branch, if you will, that is updated only when you do a fetch, pull, or clone. So the intent and purpose of the remote tracking branch is to essentially know how far you progressed since the last time you made a fetch. Okay, so now in our example here, let's say you fetched. Okay, now origin master, which is the remote tracking branch, which means the last time I fetched the remote master was at x3. Okay, so now somebody comes along and pushes their change x4 into the remote repository. So you get x4, but notice that nothing has happened here. We haven't fetched anything yet. Okay. You come along and make a change here called x5. Okay, so now master, it's a pointer to the latest commit. So latest commit is x5. So master will now point to x5. Okay, you don't have x4 here in your local repository. Okay, because because x4 has happened. The change to x4 has happened after you did a fetch. You haven't fetched x4 yet. Okay, but you did make a change called x5, and that's there. And at this point, you decide to do a git fetch. Okay, you git fetch from. Okay, so that's where you use the remote name. So you say git fetch origin, and I want to fetch the master branch. So you can say git fetch origin master, or just say git fetch origin. That will also work. And at this point, every time you do a fetch, pull, or a clone, the remote tracking branch will point to wherever master is. Okay, so master or remote master is in x4. So x4 will obviously get pulled down, and this origin master will now point to x4. Okay, so it will point to, so the rule to remember this is every time you do a fetch, pull, or a clone, the remote tracking branch will point to wherever remote master is pointing to. Okay, so remote master is pointing to x4, so origin master will also point to x4. And now if you do any more adds, any more local commits, this will not move. Okay, so so this is a good way to figure out, okay, last time I pulled origin was here, and since that point I've done 2 commits, I've done 3 commits, or things like that. Okay, So a useful command is git branch -vv. Let's run that. So git branch -vv. Okay. So essentially it says, okay, dev branch no issues, but master I'm ahead by one, which means I added this namaste.md file in master, which remote doesn't have, right? I've not pushed it yet. So which is why I am ahead by one. Okay, so this is a good way. So when you're essentially comparing your branch to the remote tracking branch, you will know, how far ahead or how behind are you, right? Whether you need to pull or not. Okay. So the command is git branch -vb. So as an example, let's say I make a change to welcome.md. Which all files do we have here? Okay, so we have welcome.md. I'm going to edit this file. I'm going to say today's weather is sunny. So this is welcome.md. I'm going to save this change. Okay. Now I'm going to do a git fetch. So git fetch origin. Okay. So I'm going to fetch this from the origin. Origin is pointing to the remote GitHub repository, essentially this page. Okay, so it has fetched the changes, it has not merged it yet, right? So essentially remember that pull equals fetch plus merge. So we fetched it, we have not merged it yet. Okay. So now let's look at the remote tracking branch would have gotten updated. So git branch -vv. Okay, so it says I'm ahead by one and behind by one. Previously I was just ahead by one. Behind by one means some changes happened in the remote repository. We added today's weather is sunny, and we've not merged that change in yet, right? We've only fetched that change, we've not merged that change. So the way to merge it would be you switch to the branch in which you want to accept the merge. So let's say I want to accept that merge into in master. So I git checkout master. Okay, now I'm in master and now I'm ready to accept the merge that happened to my file that I fetched in. So now you do git merge origin /master. Okay, origin /master, if you recall, is the name of the remote tracking branch. Remember this, origin /master. So essentially what's happening here is we are merging this remote tracking branch which contains the changes, right? Remote tracking branch brings in the latest master, right? Remember? So our changes, today's weather is sunny is contained here, and now we need to fold that X4 into our latest commit, which is X5, and that's we do that using a command called git merge. So git merge origin master. Okay. There you go. So now we merged it, and now if you check code, what's it? Welcome.md. Today's weather is sunny. So we merged those changes in. I realize this is a little bit confusing, but stick with me. Any questions? I'm just going to check the. Oh yeah, okay. Quite a few questions. Okay, so Tejas has a question. When we switch from dev branch from master, content of master was reflected to working directory. Why is it so? Okay, so good question. See, every time you make a when you see a master. Okay, let's say. Master, you checked in a file called A1, okay, in master, and in a child branch, let's say dev branch, you checked a file called B2, okay. So A1 in master, B2 in child branch, okay. So when you switch to that branch, the assumption we make is you want to work on when you switch to the child branch, you want to work on B2. When you switch to master branch, you want to work on A1, right? So the working directory should reflect these changes. So which is why every time you switch a branch, it will take the latest commit and essentially sort of uncompress it and set the working directory content to that. Okay, so because it makes no sense if you're in dev branch, it makes no sense for you to like work on changes that are in master. So you want to take those changes out from the working directory. The working directory should only point to stuff that's in the current active branch, which is why every time we switch branches, the state of the working directory gets updated. So hope that answers that, Tejas. Okay, Prashant has also answered that. So okay, all right. See if there are any more questions. Okay, no more questions so far. Feel free to ask questions here in the chat window. I'll be happy to answer. Okay, all right, so remote tracking branches we've looked at. Once again, remote and remote tracking branches are two entirely different entities. Remote is just a shortcut or an alias which points to the remote repository. Okay, so remote repository, or also known as upstream. Okay, and remote tracking branch is exactly that. It's just a tracking. It's a branch that gets updated every time you do a fetch, pull, or a clone, and it is updated to the same contents as your remote master. Okay. All right. So now let's look at merging in a little bit of detail, and we'll wrap up today's session after that. All right, so there are two types of merges. One is called as a fast forward merge. It's the simplest merge. So let's say, coming back to our example, let's say you have a change X1 that goes into the staging area, you commit it. Okay. So you have X1 in the local repository. You add another change called X2, put it in the staging area, commit it, so you get X2. Master moves to point to X2. Then you create a branch called dev branch. Okay, so you create a branch, dev branch. Branch is nothing but a pointer to the latest commit. So dev branch will point to the latest commit, which is X2. You switch to that branch, git checkout dev branch. Okay, and then the contents of the working directory will be updated to reflect dev branch, which is X2, which is same as master. So no changes here. You make a change here called X3 in the working directory, add to the staging area, and then git committed. So you get X3. So since the master is not the active branch, it has no idea X3 was created. Dev branch is the active branch, so the dev branch knows about X3. So dev branch will now move forward, okay, to point to X3. Now you do git checkout master. So working directory, its state will be X2, okay, because working directory refers to master, which is pointing to X2. So so essentially X2 will be uncompressed and put back into the working directory. And then let's say you want to merge dev branch changes. So let's say you created dev branch to work on a hot fix or some bug fix or something. Okay, and then you realize, okay, I've created this branch, I've fixed a bug. Now I need to merge it into master. So when you look at it visually, the easiest way to do a merge visually is just to roll master forward to X3, right? Correct? Because when you are essentially merging X3 into X2, so essentially you'll have both changes there. So you need to get both changes. So the easiest way to do that is to just forward master to point to X3. So now master has X3 and X2 as well. Okay. So that's the simplest merge. It's called as a fast forward merge. Okay. So let's see if we can do a very quick example here. So let's say, so we have all these changes that have happened here. Let's create a branch. It's called git branch child branch. and let's check out to that branch. Okay, now switch to this child branch. Git branch. We will show that I'm in the child branch, and here I'm going to create a file here. Let's call it aloha.md. Okay, I'm running out of synonyms for hello, welcome, namaste. Okay, yes, aloha world. Okay. And I git add that file, aloha, and I git commit that file. Okay. Now this change has happened only in dev branch. Master has no idea that aloha exists, right? So essentially the change is exactly the same as this, right? So I had master, then I created a branch called dev branch here, okay? And then I created a commit called aloha, and dev branch is now pointing to aloha. In order to merge that aloha changes into master, the simplest way is to, just roll for, visually you can see it is fast forward master to x3, and then the changes will be merged. So the way we do it is we do a git. So you first check out to whatever branch where you are going to accept the change. So you are going to accept the change into master. You are going to merge it into master. So git checkout master. Okay. So do a dir. Aloha is not there as expected, and then you do a git merge and the name of the branch which you want to merge. So that would be child branch. Okay. So you are merging child branch into master, and there you see it's a fast forward merge. Okay. See this? So essentially, master just moved forward by one commit, and that's it. Changes have been merged. So now, if you look do a dir, you will see aloha.md has been pulled into master. Okay, so this is the simplest kind of a merge called fast forward, where essentially the child branch is just ahead by one or two commits, and the easiest way to merge them into master is just to fast forward master by one or two commits. All right, now let's look at something called as a more complicated type of merge. What's happening? Okay, it's called a three-way merge. Okay, so this is a slightly more complicated scenario. So similar setup. You have x1, x2 master pointing to x2. Then you create a dev branch. Then you go ahead and make some changes into the dev branch. Okay, and you make some changes into master as well. Okay, so now master and dev branch have deviated, right? So they've deviated from x2. So in order to create a merge, Git will have to refer to both x3, x4, and its least common ancestor. So that would be x2. So that's why it's called a three-way merge. So x2, x3, and x4 will be taken into consideration to create the merged commit called x5, and now master will point to that, right? So I said, so this is called a three-way commit. Let's see if we can do an example. Okay, so let's create. So let's git checkout master. We are on master. So let's do a git branch. Let's call it child1, child2. Okay, git checkout child2. Okay, and let's create a file here. Child2.md. Save this file. Okay, git add child2 git commit dash n. Okay, so we now let us switch back. Check out, switch back to master. Okay, and let's create another file here. So you see child2.md will not be there because this is a master which has no idea that child2.md exists. So master will now will create another file in master. So let's do notepad. Let's call it master.md. Okay, save this. Git add master.md, git commit dash m master.md. Okay, so child2 branch created child2.md, master branch created master.md, right? So now this is like we'll have to do a three-way merge. So you first switch to the branch where you are going to accept the changes. Okay, so let's say okay, I want to accept the changes in master, so I want to merge dev branch or merge child2 into master. So we are going to do git checkout. I think we are already in master, but yeah, we are already on master, and now we'll do git merge child2. Okay, so now there were two changes that happened since we deviated. So child2.md, master.md, and in order to merge these changes, Git will have to go to the least common ancestor and take that commit as well. So it's a three-way merge. Okay, so there it says merge made by recursive strategy, right? So essentially x3, x4, or x2 were taken into consideration. And now you'll see both child2 and master have been merged. Okay. So that pretty much brings us to the end. Oh, we still have to. Somebody asked about Git. Somebody asked about conflict markers, right? How to resolve merge conflicts. So let me show an example, right? So I've accumulated all these changes here. I've not pushed them out yet, right? So what I'm going to do is I'm going to go to the Git repository, and let's see. I'm going to create a file here called master.md. Okay, we just created one locally, and let's just assume somebody created another file called master.md. Okay, and we'll call this is another master file. Okay, so somebody created something on the remote server, you created something on the local repository, and now when I pull down, it's going to conflict. Okay, so I'm going to do a git h origin. Okay, and now when I do a git merge origin / master, it's going to throw up a merge conflict because my master.md and the one that was pushed, that was created remotely, there are two separate versions of the same file. So you're going to run into a merge conflict, right? So it says merge conflict in master.md. So how do you resolve it? So just open master.md using your code editor. So these are known as conflict resolution markers. Okay, so this is your current change which has happened locally, and this incoming change has happened remotely. Okay, so now it's up to you. So various editors have different some like Visual Studio has a auto merge functionality, or you can resolve the merge conflict manually. So essentially resolving the merge conflict means removing the conflict markers. So let's say or you can create a custom change. So let's say this is the combined master file. So you can accept either the server version, or you can use your own, you can accept the local version, or you can create a combined fix, right? So I choose to make a combined fix here. Say, save that. Okay, git add that file, and then git commit that file. Okay, and then do a git push. And done, right? So now, if I look at the master.md, it should be the combined changes. Oh wow, something went wrong here. Okay, so we did a git push. Okay, looks like something went wrong. I'll take a look at this later. Wait a second. Shows no changes. Interesting. Which branch am I in? I'm in master. I'm really puzzled why this is happening. Don't know. I'll have to take a look and look into this. That was supposed to work. Anyways, let's take a look at a couple of comments. So Prithvi has a question: if Aloha MD exists in both child and master, child branch has Aloha World, master as Hello World. Once merging is done, so if it's the same file with different contents, you are going to run into a merge conflict, Prithvi. So you'll have to resolve the merge conflict manually. Srinivas says, don't think you have pushed it. I actually just did push it. So I'm still confused about why I'm getting the conflict resolution marker. But anyways. Okay, so let's do a git pull. Okay, and then do a code master.md. Okay. If origin the difference. Okay. Anyways, I'll have to take a look at why this why this merge conflict is still showing up on the remote repository but not on the local repository. Questions? All right. So if there are no more questions, what we'll do is we'll schedule one more talk on Git, and this time we'll look at some advanced concepts like rebasing and Git hooks, ref logs, and all that. So we'll schedule something maybe in another 2 weeks, and then we'll take a look at. Yeah. Okay. So Prithvi has a suggestion that maybe we can make another change here. Let's give it a try. What was that file? Master.md. Yes. Okay. Save. Git add master.md. Okay. Git commit. Line endings it's complaining about. Git commit. Okay. And git. Yep, weirdly enough, that worked. Oh, I think I know what the issue was. So what happened was when we first made that change, we should have, here when we had the merge conflict, after you resolve the merge conflict, you should just git commit the changes. We accidentally also did a git add. Okay, so we added master.md. So that was the mistake. We should have just gone directly to git commit -m after resolving the merge conflict. So okay, but anyways, thanks Prithvi for pointing this out. I think it's fixed now. So if you have any questions, please feel free to type them on the command window, or send us an email at support@skewcode.com. And we'll definitely try to address them. So next webinar that is coming up is Introduction to TypeScript on November 1st, which is a Wednesday evening at 7:30. We'll be talking about TypeScript and how it is used in we'll compare it with ECMAScript 6 and we'll see how it's used in a lot of JavaScript language frameworks, like how do you integrate TypeScript with Angular, TypeScript with Node, etc. So yeah, I hope you can all join us. So thank you everyone. Thanks Prashant for helping moderate. And thanks to all our viewers. And we'll see you again hopefully on November 1st for the TypeScript webinar. Okay. Thanks everyone.